Just like the famous saying, space is the final frontier. Space is vaster than we comprehend, and filled with phenomenons we barely understand. While we have watched the heavens for a millennium, space explorations and findings only began in the 20th century, and some of these findings are more incredible than we thought. In today's video, we are going to discuss all that is in outer space with important facts and discoveries. Outer space, commonly shortened to space, is the region that exists beyond Earth and its atmosphere, and between celestial bodies. Outer space is not completely empty. It is a hard vacuum containing a low density of particles, consisting more of a plasma of hydrogen and helium, as well as electromagnetic radiation, magnetic fields, dust, and cosmic rays. The basic temperature of outer space, set by the background radiation from the Big Bang, is 2.7 kelvins, or negative 270.45 Celsius, or negative 454.81 Fahrenheit. The plasma between galaxies is known to account for half of the baryonic matter in the universe, having a density of less than 1 hydrogen atom per cubic meter, and the temperature of millions of kelvins. Local concentrations of matter have condensed into the stars and galaxies. Studies also show that 90% of mass in most galaxies is an unknown structure called dark matter, which interacts with other matter through gravitational force. Outer space does not begin at a definite altitude above the Earth's surface. The Kármán line, an altitude of 100 kilometers, or 62 miles, which is above sea level, is normally used as the start of outer space in space treaties, and also for aerospace records keeping. This led to the International Space Law, which was established by the Outer Space Treaty and entered into force on October 10th of 1967. This treaty includes any claims of national sovereignty and allows all states to freely explore outer space. Humans began the physical exploration of space during the 20th century with the invention of high-altitude balloon flights. This was followed by crew rocket flights and then crewed Earth orbit, which was first achieved by Yuri Gagarin in 1961. Due to the high cost of getting into space, human spaceflight has been narrowed to explore low Earth orbit and the Moon. Although uncrewed spacecrafts have reached all of the known planets in the solar system, outer space represents a demanding environment for human exploration because of the dangers of vacuum and radiation. Microgravity also has a bad effect on human physiology that causes both muscle atrophy and bone loss. In addition to these issues, the economic cost of putting objects, including humans, into space is very high. Now, let's dive into the formation of space. The size of the whole universe is not known, and it might be infinite to an extent. According to the Big Bang Theory, the very early universe was extremely hot and dense, about 13.8 billion years ago, which grew out at a fast rate. About 380,000 years later, the universe had cooled well enough to allow protons and electrons to combine and form hydrogen, which is called the Recombination Epoch. When this happened, matter and energy were broken down, allowing photons to travel freely through the continually widening space. The matter that remained following the initial expansion has gone through gravitational collapse to create stars, galaxies, and other astronomical objects, while leaving behind a deep vacuum that forms what is now called outer space. As light has a definite velocity, this theory also constrains the size of the directly observable universe. The present-day shape of the universe has been determined from measurements of the cosmic microwave background using satellites. These observations point out that the perpetual geometry of the seen universe is flat, meaning the photons on equivalent paths at one point remain parallel as they travel through space to the limit of the observable universe, except for local gravity. The flat universe, mixed with the measured mass density of the universe and the speeding expansion of the universe, shows that space has non-zero vacuum energy, which is called dark energy. There are also estimates that put the average energy density of the present-day universe is equal to 5.9 protons per cubic meter, including dark energy, dark matter, and baryonic, or ordinary matter composed of atoms. The atoms account for only 4.6 of the total energy density, or a density of 1 proton per 4 cubic meters. The density of the universe is seen as something not uniform. It ranges from reasonably high density in galaxies, including very high densities in the composition within galaxies, such as planets, stars, and black holes. Unlike matter and dark matter, dark energy seems to not be concentrated in galaxies. Although dark energy may report for a majority of the mass energy in the universe, dark energy's influence is 5 orders of magnitude smaller than the impact of gravity from matter and dark matter within the Milky Way. The environment of space is also very unique to us. Outer space is the closest known estimation to a perfect vacuum. It has no friction, allowing stars, planets, and moons to move freely along their normal orbits, following the original formation stage. The deep vacuum of intergalactic space is not lacking matter, as it contains a few hydrogen atoms per cubic meter. By comparison, the air humans breathe contains about 1,025 molecules per cubic meter. The low density of matter in our outer space means that electromagnetic radiation can move across great distances without being scattered. In spite of this, extinction, which is the absorption and scattered of photons by dust and gas, is an important factor in galactic and intergalactic astronomy. In outer space, there are more planets than stars in our galaxy. Currently, we have 8 planets. The inner, rocky planets are Mercury, Venus, Earth, and Mars, while the outer planets are gas giants, Jupiter and Saturn, and ice giants, Uranus and Neptune. Beyond Neptune, a fresh class of smaller worlds called dwarf planets reign, including the popular Pluto that was discovered. Thousands more planets have been discovered beyond our solar system, which scientists call exoplanets. The main difference between a planet and a dwarf planet is the type of object that shares its orbit around the Sun. Pluto, for example, has not cleared its orbit of similar objects, while Earth or Jupiter has no similarly sized worlds in the same way around the Sun. Just like planets, dwarf planets are generally round and orbit the Sun. There are likely thousands of dwarf planets waiting to be discovered beyond Neptune. The 5 most popular and known dwarf planets are Ceres, Pluto, Makemake, Haumea, and Eris. Except for Ceres, which lies in the main asteroid belt, these small worlds are located in the Kuiper belt. They're considered dwarf planets because they are massive, round, and orbit the Sun, but haven't cleared their orbital path. Pluto was discovered in the year 1930 and was officially reclassified as a dwarf planet in 2006. It is the most popular dwarf planet and is also the largest in size and the second largest in mass. Pluto has 5 moons. The largest, Charon, is over half the size of its host. Pluto's orbit is not circular like those of other planets, and it actually crosses Neptune's orbit, and that means that Pluto is sometimes closer to the Sun than Neptune is. It takes Pluto nearly 250 years to complete one trip around the Sun. Eris is located beyond the orbit of Neptune and completes one trip around the Sun every 557 years. It is slightly smaller than Pluto, but it actually contains over 25% more matter. The discovery of this denser dwarf planet in 2005 was what made Pluto to be classified as a planet. To explain this disruption, Eris was named after the Greek goddess of discord. Because Eris is so far away, no surface detail can be seen by the instruments, but astronomers have detected the presence of methane ice, and they believe Eris's surface is similar to that of Pluto. Also, Ceres is the largest object in the asteroid belt between the orbits of Mars and Jupiter. This dwarf planet contains about a third of all the matter found in the belt. Its near-spheric shape means that this rocky ice body is not considered an asteroid. Ceres is also the only planet located inside the orbit of Neptune. It takes Ceres 4.6 years to complete one trip around the Sun. Scientists suspect that this special dwarf planet may even have an ocean of liquid water hidden under the layer of ice. Makemake and Haumea are both located in the Kuiper belt. They were both discovered by the same team of astronomers. Makemake is reddish in color, similar to Pluto. They both have fast rotation, and also take them close to 300 years to orbit the Sun. There are many wonders and speculations of space, both known and unknown to man. If you would like to know more discoveries and facts about outer space, subscribe to the channel, and turn on post notifications to be alerted when we post new content. As usual, don't forget to like this video.